Welcome back in lecture series on topic chemical thermodynamics. In last video, we have studied bond enthalpy, an average bond enthalpy in case of polyatomic molecules, and how to calculate standard heat of reaction or standard enthalpy change of reaction using the standard bond enthalpies of reactant molecules and standard bond enthalpy of product molecules. Now today in this lecture we will solve numerical problems based on bond enthalpy, and for that we have to use this formula. Standard enthalpy change of reaction is equal to sum of standard bond enthalpy of reactant bond minus sum of standard bond enthalpies of product bond. That means an amount of energy or enthalpy change required to break the reactant bond minus amount of energy or enthalpy change required to break, remember here, required to break the bonds in product side. So the sum of standard bond enthalpies of reactant bond minus sum of standard bond enthalpies of product bond. And you know that whenever product is formed, then whenever any bond is formed, then energy is released. And the same amount of energy is required to break these bonds, and therefore here the sum of standard bond enthalpies of reactant bond minus sum of standard bond enthalpies of product bond. Only the sign is different one or opposite one. So formula is what? Standard enthalpy of reaction is equal to summation of standard bond enthalpies of reactant bond minus summation of standard bond enthalpies of product. Now we will solve problem based on this. So let us see this problem, that is calculate standard enthalpy change of the reaction. We have to calculate standard enthalpy change of reaction. That means the delta H0 R that we have to find out. For which reaction? 1 mole of methane gas, when it reacts with 1 mole of chlorine gas, then it gives you methyl chloride, 1 molecule of methyl chloride and 1 molecule of HCl gas. Here all the reactant and products are in their standard state, and therefore we have to calculate what? The standard heat of reaction for this particular reaction. Remember here, the reactants are in this reaction methane and chlorine. These are the reactant. And methyl chloride and HCl. These are the product. Now what is given to you? Bond enthalpies are given to you. And how much these enthalpies? That is, see here. The bonds CH bond, chlorine-chlorine bond, carbon-chlorine bond and HCl bond. The bond enthalpy of carbon-hydrogen bond is 414 kilojoules per mole. Chlorine-chlorine bond is 243 kilojoules per mole. And carbon-chlorine bond is 330 kilojoules per mole. And hydrogen-chlorine bond is 431 kilojoules per mole. So, formula we have to use, that is standard enthalpy of reaction is equal to sum of or summation of standard bond enthalpy of reactant bond. Now, which are reactant here? Methane and chlorine. So, bond enthalpies of methane, total bond enthalpies of methane and bond enthalpy of chlorine molecule. That is the sum of or summation of standard bond enthalpies of reactant bond minus summation of standard bond enthalpies of product. What is the product here? Methyl chloride and hydrogen chloride. So, we have to add the bond enthalpy of HCl bond and the bonds present in CH3Cl. So, while solving such a type of example, you have to first calculate the number of bonds. So, here carbon is the central atom and 4 hydrogen atoms are attached to the central carbon atom. So, 4 carbon hydrogen bonds are present in 1 mole of methane. Chlorine is a diatomic molecule. So 1 chlorine, and here 1 mole of chlorine is required. So 1 chlorine-chlorine bond is present. And on product side, CH3Cl is formed. CH3Cl is formed, that is Out of 4 valencies of carbon, 1 is satisfied by chlorine. So one chlorine carbon chlorine bond is there, and other 3 bonds are carbon hydrogen bonds are there. So total 4 bonds are there. Out of these 3 are carbon hydrogen and 1 is carbon chlorine. And in case HCl is a diatomic molecule, so one HCl bond is there. Now formula is what? Standard enthalpy of reaction is equal to summation of standard enthalpies of reactant bond minus summation of standard enthalpies of product bond. So we have to write first the formula for this particular reaction. So standard enthalpy of reaction is equal to 4. So why we have used here 4? We have to multiply the standard bond enthalpies of CH by 4. 4 carbon hydrogen bonds are there. So 4 into standard bond enthalpy of carbon hydrogen bond plus 1. Here only one chlorine bond is there. So 1 into standard bond enthalpy of chlorine bond minus 3 into standard bond enthalpy of carbon hydrogen bond. Here 3 bonds are there, carbon hydrogen. So 3 into standard bond enthalpy of carbon hydrogen bond plus 1 carbon chlorine bond is there. So 1 into standard bond enthalpy of carbon chlorine bond, and 1 hydrogen chloride bond is there. So 1 into standard bond enthalpy of hydrogen chloride bond. So here on reactant side 4 carbon hydrogen bonds are there, and on product side 3 carbon hydrogen bonds are there. So 4 minus 3, that is 1 is remains. So this 3 is cancelled, and therefore the new formula becomes what? Standard bond enthalpy of reaction is equal to, instead of 4, only 1 is remain on reactant side by cancelling these 3 on product side. So 1 into standard bond enthalpy of carbon hydrogen bond plus 1 into standard bond enthalpy of carbon chlorine bond minus, here it is cancelled, all the 3 bonds, carbon hydrogen bonds are cancelled, bond enthalpies, and therefore 1 into standard bond enthalpy of carbon chlorine bond plus 1 into standard bond enthalpy of hydrogen chloride bond. Now we will substitute the values. So in this equation, so here you know that carbon hydrogen bond enthalpy is given to you and it is 414. So 1 into 414 plus, in this reaction chlorine molecule, methane molecule reacts with chlorine. So 1 chlorine bond is there. So 1 into 243 minus 1 carbon chlorine bond is there. So 1 into 330 plus 1 hydrogen chloride. So 1 into 431 kilojoules per mole. So here 414 plus 243 minus 330 plus 431. And therefore the standard enthalpy of reaction is equal to, this addition is, sum of these two is 657 minus this 330 plus 431, that means 761, and that is equal to, sign is minus because here 657 minus 761, so the sign is minus, and it is how much? 104 kilojoules. So this is what? The standard enthalpy of the reaction. Like this you can solve the problem. Very simple it is. I hope you understood how to solve the numerical problems based on bond enthalpy. We will see one more problem, that is problem number 2. The standard enthalpy change of the reaction. Now this is the reaction. Propane C3H8 means 1 mole of propane gas is there. It reacts with, it is a combustion reaction. See here, 5 oxygen atom. It reacts with how many oxygen? 5 oxygen molecules, and it gives 3 moles of carbon dioxide and 4 moles of water. This is a general reaction, and standard enthalpy of reaction now it is given to you. In last problem we have calculated it, and in this problem this is given to you, that is minus 2050 kilojoules. This is the standard enthalpy of reaction. Now what you have to calculate? Bond enthalpies are also given, that is bond enthalpy of carbon hydrogen is 414, carbon carbon bond is 347, carbon oxygen double bond is 741, and oxygen hydrogen bond is 464. We have to calculate what? Calculate bond enthalpy of oxygen bond in oxygen molecule. And in the reaction 5 oxygen molecules are there. You have to find out what? The standard bond enthalpy of oxygen molecule. That means 1 mole of oxygen. And here reaction in mole, 5 mole of oxygen. Remember this point. Then formula as usual, that is standard enthalpy of reaction is equal to summation of standard enthalpy of reactant minus standard enthalpies of product. Now what are the reactants here? Propane and oxygen. These are the reactant, and carbon dioxide and water are the product. Bond enthalpies of these bonds are given to you. Now we have to write the first, you have to write what? The structural formulas of all the reactants and product, and you have to count the number of bonds, each type of bond present in reactant molecule as well as product molecule. So propane is there. Propane, 1 mole of propane gas reacts with oxygen. So propane has structure CH3, CH2, CH3. So how many bonds are there? See, count here. 1, 2, 3, 4, 5, 6, 7 and 8. How many carbon hydrogen bonds are there? 8. And carbon-carbon bonds? Only 2. So it contains 8 carbon hydrogen bond and 2 carbon-carbon bond. Then oxygen, 5 moles of oxygen atoms are there. Oxygen-oxygen double bond is present in oxygen molecule. It is a diatomic molecule. Now 5 oxygen atoms are, oxygen molecules are there. So 5 oxygen double bond oxygen is there. Then carbon dioxide. The structure of carbon dioxide is like this. C double bond O, C double bond. So how many carbon oxygen bonds are there? 1 molecule contains 2 carbon oxygen bond. Therefore 3 molecules contain how many? 6 carbon oxygen bonds. And here water molecule, HO, 1 molecule of water molecule contain 2 OH bond. So 4 molecules of water contain 8 OH bonds. So this, like this, you have to first write the structure of the reactant and product, each reactant and product, and then count the number of each type of bond present in reactant and product side. Now substitute the values in the given formula. So standard enthalpy of reaction is equal to, the on reactant side propane is there and oxygen. So propane contain 8 carbon hydrogen bond. So 8 into standard enthalpy of carbon hydrogen bond plus 2 carbon-carbon bonds are there. So 2 into standard enthalpy of carbon-carbon bond plus on reactant side 5 oxygen molecules are there. So 5 into standard bond enthalpy of oxygen-oxygen double bond minus here carbon-oxygen bond, 3 molecules of carbon dioxide are formed in the reaction. So here 1 molecule contain 2 carbon oxygen bond. So 3 molecules contain 6 carbon oxygen bond. So 6 into standard bond enthalpy of carbon oxygen bond plus here 4 molecules of water are there. So 8 into standard bond enthalpy of oxygen hydrogen bond. So here 4 molecules of water are there. 4 into 2, that is 8. 3 molecules of carbon dioxide. So 3 into 2, that is here 6. And 5 molecules of oxygen and 1 molecule of propane is formed, which contain 2 carbon-carbon bonds. So 2 into standard bond enthalpy of carbon-carbon and 8 carbon hydrogen bonds are there. So 8 into standard bond enthalpy of carbon hydrogen bond. So now we will substitute the values. You know the bond enthalpies are given in your problem. So we will substitute the values. Here standard enthalpy of reaction is given, that is minus 2050, and 8 bonds are there. So 8 into carbon hydrogen bonds are there. So 8 into bond and standard bond enthalpy of carbon hydrogen bond, that is given to you, and it is 414. So 8 into 414 plus unreacted sign oxygen is there. So here 5 into oxygen bond, and 2 carbon bonds are also present in propane. So 2 into standard enthalpy of carbon, that is equal to 347. So this is what the total sum of bond enthalpies of reactant bond minus sum of bond enthalpies of product bond. So here 6 bonds are there, carbon oxygen. So 6 into 741, and 8 OH bonds are there. So 8 into 464. Now calculate it. 8 into 414 is equal to 3312 plus 2 into 347, that is equal to 694, plus it is, you have to calculate this oxygen bond enthalpy. So 5 into oxygen bond minus here 6 into 741, that is equal to 4446, plus 8 into 464, that is equal to 3712. So add this. Here minus 2050 is equal to 3312 plus 694, that is equal to 4006, 4006, plus you have to calculate it, 5 into oxygen bond minus 4446 plus 3712, it is equal to 8158. Now calculate it. See here, minus 2050 minus 4006 plus 8158 is equal to 5 into oxygen bond, that is equal to how much? Minus plus, so minus 6056 plus this 8158 is equal to 5 into oxygen bond enthalpy, and that is equal to how much? 2102 is equal to 5 into oxygen bond enthalpy. Now this is for 5 molecules of oxygen. We have to calculate for 1 mole. So 2102 divided by 5, that will give you the bond enthalpy of single oxygen bond, and it is equal to how much? 420. So standard bond enthalpy of oxygen bond is equal to how much? 420 kilojoules per mole. So such a type of a simple problems are asked on this. Sometimes in MCQ also such a type of a questions are asked, but whenever MCQ is asked, it is not necessary to write the formula and solve this example in a stepwise manner. You can directly calculate what? By knowing the bond enthalpies, you can calculate the bond enthalpy of a particular bond or standard enthalpy change of the reactions. So solve such a type of a problem. Thank you.